You ever look at the device you're watching this on and just wonder how it came to be? I mean, how did it go from just an idea in someone's head to this complex thing in your hands? Well, today we're going to pull back that curtain and show you exactly how it's done. Right? It's the big question behind every single piece of tech we use. How does that little spark of an idea, that flash of inspiration, turn into an actual working gadget? That's what we're going to break down. And the answer, almost every single time, comes down to this: the printed circuit board, or PCB. Honestly, the best way to think about it is as the central nervous system for any electronic device. It's the physical platform that takes a circuit diagram, an abstract idea, and gives it a body, letting electricity and information flow exactly where they need to go. Okay, so where does a journey like this even begin? Well, like any great building or creation, it all starts with a plan. This is the blueprint phase. Every single PCB, and I mean every one, starts its life as a schematic. This is literally the architect's drawing for your device. And, it doesn't really matter if it's a super sophisticated digital file from some fancy software or a sketch on a napkin. This document lays out every component, every connection. It's the absolute source of truth for the entire project. So with that blueprint in hand, the next huge decision is about the foundation. You have to pick what exactly you're going to build your circuit on. And you've got options, lots of them. You have simple, single-layer boards, but for something really complex, like your phone, you're going to need multi-layer boards that literally stack circuits on top of each other. You can go for rigid boards that don't bend at all, or even flexible ones for tech that needs to fit into really tight, awkward spaces. The right choice, it completely depends on what your product needs to do.
And this is where it gets really interesting. Look at the contrast here. On one side, you have your rigid PCBs. Those are the solid, unbending workhorses inside your computer or your TV. They're strong, they're cost-effective. But then on the other side, you've got flexible PCBs, which you can literally bend and shape. This makes them perfect for things like wearables, modern cameras, or really any gadget where space and weight are a huge issue.
All right, so having a great design is one thing, but can you actually build it? And more importantly, is it going to work reliably? This next part, this is what separates a cool weekend project from a professional, mass-produced product. To get from a design to a real-world product, you have to pass 3 absolutely critical checks. First up is DFM, or Design for Manufacturing. This is just asking, can we build this efficiently and at scale? If you get this wrong, your costs can just explode. Second is DFT, Design for Testability, which makes sure you can actually check for flaws. Without this, you could ship thousands of faulty units. And finally, EMC, Electromagnetic Compatibility, which basically confirms your device won't mess with other electronics or have them mess with it. That's a huge step for legal and safety reasons. Now that we've got a solid, tested design, we can zoom out and look at the whole journey from that very first sample all the way to a finished product sitting on a store shelf. And this really shows you that just building the board is only one piece of a much larger puzzle. The whole process involves creating prototypes, writing the software or firmware that makes it smart, then moving into mass production with quality control, getting all the necessary industry certifications, and finally, managing all the logistics to get it into the hands of users. It's a whole thing. Now, I know this process might seem really complex, but modern services have made it more accessible than ever before. So let's take a look at what it actually takes to get your own project off the ground. In fact, the barrier to entry might be a lot lower than you think. Some companies out there even offer initial design services for free for first-time customers. For independent creators and entrepreneurs, that's an absolute game changer. So, to take advantage of an offer like that, you typically need to be a new customer and your board design has to be pretty standard. The key is to come prepared with those core things we already talked about: your schematic drawing, a list of all the materials you'll need, and any special instructions for the design. And here's a detail that is absolutely critical: ownership. Once the design is done, a reputable service will give you what are called the Gerber files. You can think of these as the master blueprints for manufacturing your board, and they are your property. This is so important because it means you own your intellectual property and you can take that design to any manufacturer you want anywhere in the world. So there you have it. From a simple sketch to a real tangible product, the path is clearer and more accessible than it has ever been. It really just leaves us with one last question to think about. With these tools at your fingertips, what amazing idea are you going to bring to life?